Hi guys, so today I am going to discuss a very important question related to energy momentum concept, and the question is, suppose I have two blocks, let's say mass m1 and mass m2, and they are connected with a spring, and for which spring K is provided. Spring constant is provided, let's say 2 Newton per meter, and m1 is given to be, let's say 1 kg, and m2 is provided as, let's say 3 kg. Okay, and assume initially spring is in its natural length. Okay, so that means there is no compression or extension in the spring in starting. Okay, now what we have done, there is an impulse provided to the block of mass m1, okay, in the form of initial velocity as 10 meter per second of m1. Okay, now the question is find out the maximum compression in the spring. So here we go, this is our question. Okay, so now you can understand, this is very important question. Many times IIT JEE used to ask this type of question on this concept. Okay, I analyzed the paper of 2019 JEE Advanced. In that paper also there was a question of more than one answers were there, and this type of questions used to be asked. And this time also maybe they can ask such type of question. Either they can ask in mains or they can ask in advanced, because this question is based on two multiple concepts. So first of all, understand the question. Initially blocks are at rest, spring is not compressed at all. So now what happens when you provide a velocity of, let's say 10 meter per second in at t is equal to 0. So now what happens? You can assume now this block will start pushing this spring like this. Okay, so at that instant you can understand this spring is going to be compressed. So what this spring will do, it will also apply kx force after some time. Obviously t is equal to 0, we provided a velocity of 10 meter per second. We are seeing this situation after t time. Fine. So after t time, the situation is that we provided kx velocity, kx force. Spring has kx force, and it is actually, if you see the FBD of, let's say block m1, so kx will be applicable like that. Okay, so now velocity will be somewhere, let's say v, for example. So now what will happen, you can understand that this 10 will go down to this 10 will go down to some velocity, let's say v, and at the same time, if I see the FBD of this block, what happens, spring will push away like this. So that means this block will start moving, so this will gain a velocity of v. So when you can understand, when both the blocks, let's say one block is there, this is moving faster, okay, and this is moving slowly, because this is starting from t is equal to at t is equal to 0, this is at rest. Okay, and this is moving with 10 meter per second. So now this is moving faster, this is moving slowly. So you can assume that spring is going to be compressed, correct? Understanding this point? Okay. Now when they will acquire the same velocity v at t is equal to t, at that point of time maximum compression is going to be happening. Understanding this point? This is really important. So when they will have the same velocity, okay, then actually maximum compression is gonna happen. So and if I see the system, okay, then we can say spring force is an internal force. That means I can say I external is equal to integral f dt, f external into dt. That means I can say I external is 0. And what does it signify? That momentum, linear momentum is conserved. That means I can write initially system has this one m1 has some velocity, this is m2, this is m1, this is m2, and this has 10 meter per second initial velocity. Finally the condition will be like that this m1 will have v velocity, this spring will be compressed, let's say x max I am taking, and this is also having v velocity. So by applying momentum conservation, I can write that m1 into 10, this is the initial momentum of the system, okay, L initial is equal to L final, or I should write P initial is equal to P final, because we are using linear momentum. And now here I can write m1 into v plus m2 into v. So that means v is coming out to be m1 into 10 upon m1 plus m2. If I put the value to 10 into 1 upon, this would become 1 plus 3. So 10 by 4, that means 5 by 2 meter per second. This will be the velocity. And now I can use energy conservation, correct? Because initially system has some energy half m1 into 10 chi square, and then finally half m1 into v square plus half m2 into v square plus half k into x max square. Okay, so this will be the final kinetic energy, and this is the initial energy of the system, this is the final energy of the system. Both has to be the same. So now I can use half, or I can cancel out this half. I can say 1 into 100 is equal to this m1 v square will be common, so I can write 5 by 2 whole square into v1 by using the value of v, this v, and then this m1 plus m2 will be 4, and then half k value has been provided 2, so this will be 2 into x max square. Fine. And then I can say this 100 is going to be this is into 4, so this would be 25 by 4 into 4, 2x max square. And if you solve this, then I can get x max is equal to 75 by 2 under root. Okay, so I can write this around under root of 37.5. Okay, so you can approximately say 6 almost 6.1 for example. Okay, so 6.1 meter will be the maximum compression for the spring. So this is really important question. Understand the concept. There are two key concepts. I am repeating two key concepts. So key is linear momentum conservation, first key, and second key I have energy conservation. Okay, so guys, I hope that you got this question, and this is really very important question, because in that question there are two concepts which are used. So be very careful about these questions. In JEE Mains, if I am focusing about JEE Mains particularly for this video, so basically I am telling you the concept used to be applied in JEE Mains. Sometimes direct questions can be asked. So be very careful. Start your revision, especially for the 12th guys. Start your revisions. Give some time to the old topics. Okay. If any kind of helps, you can definitely ask me. Okay. Bye bye.